Hey everyone, and in today's video, we will see the practical implementation of linear regression using a popular Python library, scikit-learn. So before starting, I need you to inform that I'm using Jupyter Notebook here. You can use any other IDE, but it is advised to use Jupyter Notebook downloaded from Anaconda because it has all the libraries and all the other modules pre-installed and it's easy to use. So if you don't have a Jupyter Notebook, you can download the libraries with this code. Can I stop, please? Yeah. So I'll comment it out. These are the both libraries that need to be installed. Pip install scikit-learn. I'll comment this. Okay, now let's start with the coding. We'll first import numpy as a we'll first import numpy with an alias np, and from scikit-learn linear model will import linear regression. So now we'll create two NumPy arrays that will be used as some sample data. And you can even use pandas series or data table if you want. And either you can use a matrix in pandas, and there's several other options that can be opted. So first we'll create this array, np array, as we have used the alias np. So rather typing numpy will send np array, and we'll created a nested array. And if you haven't learned numpy and pandas yet, then I'll give a link in the description of one of my previous tutorials on which I have defined numpy and pandas completely. So let's get started with this. So this is the first, second one, the third, four, five. So this is our data for the x numpy array. Then here's for the y numpy array, same. And this time it's not a nested array, it would be a rather simple one with all the even numbers between 1 to 10. So 2, 4, 6, 8, and then 10. Done. Variables created, dependencies completed. Now we'll start with the implementation by creating a model. First, create a model variable that has all the dependencies from the linear regression submodule. And now we will we would have to merge this data in one to use this as one. What I mean is we need to fit x and y into one model to use them simultaneously, so that we can work on them both at the same time. So from the in the linear regression model, we need to use the x and y array. And to define this, that we need both of these array, there's a method named fit. Means we are actually fitting these arrays as a data source in the model. So this is one. Okay, now we have got the model intercept. This submodule actually contains all the data we need to print for linear regression model, like intercept, coefficient, and the prediction can be made using this model itself. So first we'll save the intercept, which can be made like this: model dot intercept, and then an underscore. Then we'll have model coefficients that can be stored like this. Let me comment this out to make it a bit clear. So this is a y-intercept, y-axis, x-axis. I hope you understand the plotting and the graph thing. If they are actually data handling chapters in pre-primary, in upper primary classes too. So this is really easy to learn already. This y-axis, x-axis, and then it the intercept part is not from the upper primary, but you can learn it. It's really easy. Then the model coefficient has to be obtained from the slope, and then we would have to make predictions. Actually, we can store this in the same block in the same cell. So predictions, the model has a method predict, and the prediction have to be made using the numpy array x. Now save this and we'll print it. We'll print the intercept first. The model intercept is, we can merge it using the f string. So for merging the data in a string using f string, we have to use these curly braces. Now we'll type intercept here. I'll copy this line, paste it 2 times. Now model coefficients are model coefficients. This recommendation list was opened using the tab key. The model predictions are, we will rather make this in a new line. So \n predictions. Now shall we print this? Great. So we have obtained a model intercept, coefficient, and prediction. So basically, this code creates a linear regression model using the linear regression class from scikit-learn. It then fits the model to the sample data x and y, which are arrays of input and output values respectively. The fit method is used to fit the model to the data. The model's coefficients, including the y-intercept, intercept underscore, and the slope, coef, the coef method underscore, are printed. Finally, the model is used to make predictions on the input data x using the predict method. And then the predictions are printed. And then important note has to be made that the above code is just an example and does not guarantee the best performance on the given data set because it's an oversimplified version just to demonstrate linear regression. To get the best performance, you need to clean your data, perform feature scaling, and also test the model on a test data set. And you can use other libraries instead of scikit-learn like stats model, TensorFlow, and many more that are available on the community. So this is it for this video, and I'll see you next time.